Hey guys, so today we're just going to be dealing with probability that involves drawing probability trees for questions. You can answer questions without drawing probability trees, however it makes life a lot easier because you have a visual representation in front of you and then you can clearly identify each step of the probability. Today we'll be dealing with and or questions using probability trees. And the prior knowledge that you require in order to understand this is just simple probability and how it works in regards to outcomes, sample space, etc. All right, so let's start and get into it. The simple basic rule that you need to understand before we continue. If the question involves and, for example, getting a blue marble and a green marble, then you have to multiply. If the question involves or, then you have to add them. So if it was a green marble or a blue marble, then you'd add the probability of getting a green marble plus the probability of getting a blue marble. And if the probability was a complementary probability where we had to do a not, you would subtract. For example, if the probability was not getting a green marble, you would do 1 because 1 is the whole probability minus the event occurring. Because we don't want to know what that event is, we want to know what everything else is. So we use subtract there. So let's go into a basic example here. It says there are 5 red pens and 3 blue pens in a box. Ahmed takes out 1 pen from the box and gives it to his friend. He then takes another one out for himself. Now reading this, we can quickly assume or understand that he doesn't put that pen back into the box. So this is a 2-step probability, where we have to then change the sample space in the second step. So let's go and draw a probability tree. Here I've identified or labeled here, this is the first pen, this whole column here is the first pen, and this is the second pen, and getting the color for the second pen. So let's have a look at how this probability tree works before we actually fill in the options. So let's go through the different roads we can go through. So the first option is he can either get a red pen or he can get a blue pen. And then after he's gotten the red pen in the first option, he can either then get another red pen or get a blue pen. But if he pulls out a blue pen first, he can then get a red pen or another blue pen. So that's how this probability tree is laid out. But now we're going to come up with some ideas or some numbers of probability in order to fill out this probability tree. So let's have a look at it first. He has 5 red pens and 3 blue pens. What is the sample space here? The sample space will be 5 plus 3, which is 8. So what is the probability of him getting a red pen? It'll be 5 out of 8. And what is the probability of him getting a blue pen? It is 3 out of 8. Remember, sample space is as a denominator at the bottom of the fraction, and all the possible outcomes for that event are on top of the fraction. Alright, so he's got the red pen as his first pen. What is the probability of him getting another red pen? Now you have to understand that, number 1, he had 8 pens to choose from. Now he only has 7. So our sample space for everything as a second pen is going to be out of 7. Everything is going to be out of 7 because that's a new sample space. 1 pen's already been taken. Now there's only 7 pens to choose from. So let's have a look. Okay, he chose a red pen, and there was 5 red pens. But let's say he chose a red pen. Now how many red pens are remaining for him to choose from? There's only 4. 4 out of 7 red pens remaining. But the blue pens, he hasn't chosen any if he chose a red pen as a first pen. So he still has 3 out of 7 remaining here. So let's go to the second option. His first pen was a blue pen, and now he wants a red pen. Now he's only chosen a blue pen. So we still have all the red pens in there. We still have 5 out of 7 red pens there. And if he chose a blue pen first, and then he wanted to choose another blue pen, he's already taken 1 blue pen out. So there's only 2 blue pens remaining out of 7 in there. And that's that whole probability tree labeled as probabilities as a fraction. Now let's go through some questions that involve using probability for that probability tree. We don't need to use the word problem anymore. It says, what is the probability they will both be blue? So this means blue and blue. Remember, when we have and, what do? We multiply. So what is the probability of blue for the first pen? 3 out of 8. What is the probability of blue for the second pen? 2 out of 7. And when we have the word and, we multiply. So it's going to be 3 out of 8 times 2 out of 7. And this is going to equal 3 out of 8 times 2 out of 7 equals 3 out of 28. Remember, always simplify your fractions to their most simplest form. 3 out of 28 is my final answer. Okay, let's move on to the next question. The next question states, what is the probability of getting a red and then a blue? Remember, now we have and again here. Because we have and, we're going to multiply again. So the probability of getting a red, which is 5 out of 8, and then after that getting a blue, which is 3 out of 7. And because there's and, we're going to multiply. So it's going to be 5 out of 8 multiplied by 3 out of 7. Now you could do this a long way by figuring it out, but the probability tree just makes it a little bit easier to understand here. So we have 5 out of 8 multiplied by 3 out of 7 multiplied by 3 out of multiplied by 3 out of 7, and we get 15 out of 56 as our probability there. Now let's go on to the last question. The last question states, what is the sum of all probabilities? Now we know mathematically sum means plus. Sum means plus or 2, add them all. So it says of all the probabilities. Now even if you didn't know how to do this, you could just look at the word sum of all. That just means add all of the probabilities up. That means we're adding 5 out of 8, 4 out of 7, 3 out of 7, 5 out of 7, 2 out of 7, and 3 out of 8. And if we add all of them up, I can write it as an algorithm so that everyone understands. 5 out of 8 plus 4 out of 7 plus 3 out of 7 plus 5 out of 7 plus 2 out of 7 plus 3 out of 8. When we add all of them up, the sum of all of these probabilities equals 3. Equals 3. Hopefully that helps you in understanding probability trees. There are different questions involving probability trees. This is just an introductory video. If you have any further questions, please don't hesitate to ask.